For a 35 amp appliance, the circuit needs to be rated for not less than 35 amps according to section 422.10 of the National Electrical Code. The plug and receptacle must be rated for not less than the circuit rating referencing section 422.33c and section 210.21 bone of the NEC. For a 35 amp circuit using number 8 copper conductors, a 40 amp breaker is needed, based on table 310.15b16. The nameplate rating on the appliance is considered the same as the overcurrent protection rating according to section 210.21a. Since the nameplate indicates 35 amps, that value is the overcurrent protection rating. If the appliance is intended for use exceeding 3 hours, the circuit rating needs to be increased to 43.75 amps, necessitating number 6 copper conductors and a 50 amp breaker. While the appliance may have functioned on a 30 amp circuit without issues, it does not necessarily imply a safe or code compliant installation. The plan to utilize number 8 copper, a 40 amp breaker, and a 50 amp plug and receptacle is generally appropriate. Consider replacing the existing number 10 sub cord with number 8 sub cord to match the branch circuit conductors. Ensure that the heat sealer is adequately grounded. Strictly adhere to the manufacturer's instructions for any specific installation requirements. The electrical code necessitates that you use the correct wire size, circuit breaker size, and receptacle for the equipment you are installing. First, determine the load of the appliance. This can be found on the nameplate of the appliance. Second, determine the correct wire size for the load. This can be found in NEC table 310.15b16. Third, determine the correct circuit breaker size for the load and wire size. This can be found in NEC section 240.4b. Fourth, determine the correct receptacle size for the load. This can be found in NEC sections 210.21 bone and 422.33c. Always consult the manufacturer's instructions for any specific requirements for the appliance. The National Electrical Code, or NEC, is a set of standards for safe electrical installations. It's updated every 3 years and is adopted by most jurisdictions in the United States. The NEC is not law itself, but it is often adopted into law by local and state governments. The NEC covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It's important to consult the NEC when planning any electrical installation to ensure that it is safe and compliant with local codes. Understanding ampacity is crucial for electrical safety. Ampacity refers to the maximum amount of electrical current a conductor can carry continuously without exceeding its temperature rating. Several factors influence ampacity, including the conductor's material, size, insulation type, and the ambient temperature. Copper and aluminum are the most common conductor materials. Copper has a higher ampacity than aluminum for the same size conductor. Larger conductors have a higher ampacity than smaller conductors. Different insulation types have different temperature ratings, which affects ampacity. High temperature rated insulation allows for higher ampacities. Higher ambient temperatures reduce the ampacity of a conductor. The NEC provides tables that list the ampacities of various conductors under different conditions. It's important to consult these tables when selecting conductors for an electrical installation. A proper conductor sizing can lead to overheating, insulation damage, and even fires. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors from overloads and short circuits. These devices interrupt the flow of current when it exceeds a safe level. Circuit breakers are resettable, while fuses must be replaced after they blow. The NEC specifies the maximum overcurrent protection for different conductor sizes. It's important to select overcurrent protection devices that are properly sized for the conductors they protect. Using overcurrent protection that is too large can allow conductors to overheat, while using overcurrent protection that is too small can cause nuisance tripping. Grounding is another essential aspect of electrical safety. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trip overcurrent protection devices quickly. Grounding also helps to reduce the risk of electric shock. The NEC specifies the requirements for grounding electrical systems. It's important to follow these requirements carefully to ensure a safe electrical installation. Grounding electrodes, such as ground rods and ground plates, are used to connect the electrical system to the earth. The size and type of grounding electrode depend on the size of the electrical system and the soil conditions. Grounding conductors are used to connect equipment and enclosures to the grounding system. The size of the grounding conductor depends on the size of the circuit conductors. Receptacles are used to provide a convenient way to connect electrical equipment to the electrical system. Receptacles are available in different configurations to accommodate different types of plugs. The NEC specifies the requirements for installing receptacles. It's important to follow these requirements carefully to ensure a safe electrical installation. Receptacles must be properly grounded to protect against electric shock. Ground fault circuit interrupters, or GFCIs, are used to protect against ground faults. GFCIs detect small imbalances in current flow and interrupt the circuit quickly. GFCIs are required in certain locations, such as bathrooms, kitchens, and outdoor areas. Electrical panels are used to distribute electrical power throughout a building. Electrical panels contain circuit breakers or fuses that protect individual circuits. The NEC specifies the requirements for installing electrical panels. It's important to follow these requirements carefully to ensure a safe electrical installation. Electrical panels must be properly grounded to protect against electric shock. The electrical panels must be accessible and have adequate working space. Wiring methods refer to the way that electrical conductors are installed. The NEC specifies the acceptable wiring methods for different applications. Common wiring methods include non-metallic sheath cable, or Romex, metal-clad cable, or MC cable, and conduit. Each wiring method has its own advantages and disadvantages. Non-metallic sheath cable is commonly used in residential wiring. Metal-clad cable is more durable than non-metallic sheath cable. Conduit provides the best protection for conductors. Electrical boxes are used to enclose electrical connections. Electrical boxes protect the connections from damage and provide a safe place to make splices. The NEC specifies the requirements for installing electrical boxes. It's important to follow these requirements carefully to ensure a safe electrical installation. Electrical boxes must be properly grounded to protect against electric shock. Electrical boxes must be accessible and have adequate working space. When working with electricity, it's important to follow safe work practices. Always to energize circuits before working on them. Use insulated tools to prevent electric shock. Wear appropriate personal protective equipment such as safety glasses and gloves. Never work on electrical equipment when you are wet or tired. If you are not comfortable working with electricity, hire a qualified electrician. Understanding electrical theory is essential for anyone working with electricity. Voltage is the electrical potential difference between 2 points. Current is the flow of electrical charge. Resistance is the opposition to the flow of current. Ohm's law states that voltage is equal to current times resistance. Power is the rate at which electrical energy is used. Power is equal to voltage times current. Electrical circuits can be either series or parallel. In a series circuit, the current is the same throughout the circuit. In a parallel circuit, the voltage is the same throughout the circuit. Electrical components such as resistors, capacitors, and inductors are used to control the flow of electricity in circuits. Resistors limit the flow of current. Capacitors store electrical energy. Inductors oppose changes in current. Transformers are used to increase or decrease voltage. Transformers consist of 2 or more coils of wire or wound around a common core. The ratio of the number of turns in the coils determines the voltage transformation ratio. Electrical motors are used to convert electrical energy into mechanical energy. Electrical motors consist of a stator and a rotor. The stator is the stationary part of the motor. The rotor is the rotating part of the motor. Electrical generators are used to convert mechanical energy into electrical energy. Electrical generators consist of a stator and a rotor. The stator is the stationary part of the generator. The rotor is the rotating part of the generator. Batteries are used to store electrical energy. Batteries convert chemical energy into electrical energy. Batteries are available in different sizes and voltages. Solar panels are used to convert sunlight into electrical energy. Solar panels consist of photovoltaic cells. Photovoltaic cells convert sunlight directly into electricity. Wind turbines are used to convert wind energy into electrical energy. Wind turbines consist of blades that rotate a generator. The generator converts the mechanical energy of the rotating blades into electrical energy. The NEC provides specific guidelines for appliance circuits, particularly concerning heat-producing appliances. Section 422 addresses appliances, and subsections detail specific requirements for circuit sizing, overcurrent protection, and wiring methods. When a heat sealer is considered a continuous load, meaning it operates for 3 hours or more, the circuit must be rated for 125% of the appliance's nameplate rating. This is a critical factor in determining the appropriate conductor size and overcurrent protection. The overcurrent protection device, typically a circuit breaker, protects the circuit from overloads and short circuits. Its rating should not exceed the ampacity of the conductors. However, the NEC allows for rounding up to the next standard size breaker if the conductor ampacity doesn't perfectly match a standard breaker size, as long as the conductor is protected. Receptacles and plugs must be rated for the amperage of the circuit they serve. Using a receptacle or plug with a lower rating than the circuit's amperage is a safety hazard and a code violation. The cord connecting the heat sealer to the power source must also be sized appropriately for the load. Flexible cords, like SU, have ampacity ratings based on their size and construction. It's essential to ensure the cord's ampacity matches or exceeds the appliance's current draw and the circuit's rating. Grounding is a critical safety measure for all electrical equipment. A proper grounding system provides a path for fault current to flow back to the source, tripping the overcurrent protection device and minimizing the risk of electric shock. Check with your local jurisdiction for additional regulations on top of the NEC. State and local codes may amend or add to the NEC requirement. The heat sealer's installation should always comply with the manufacturer's instructions. These instructions provide specific guidance on wiring, grounding, and other installation requirements. The manufacturer may also specify the type and size of cord and plug to be used. It is critical to choose the right wiring method. The wiring method selected must be suitable for the environment in which the heat sealer is used. Factors to consider include moisture, temperature, and the presence of corrosive substances. Conduit provides the best protection for conductors in harsh environments, while cable wiring may be suitable for dry, indoor locations. Regular inspection and maintenance of the heat sealer and its electrical connections are essential for ensuring safe and reliable operation. Check for loose connections, damaged cords, and other signs of wear and tear. Repair or replace any damaged components promptly. For portable appliances like heat sealers on wheels, the cord must be flexible and suitable for repeated bending and flexing. SU cord is a common choice for portable appliances due to its oil resistance, weather resistance, and flexibility. The length of the cord should be minimized to reduce voltage drop and the risk of damage. When selecting electrical components, choose products that are listed by a recognized testing laboratory such as Underwriters Laboratories or Intertech. These listings indicate that the products have been tested and meet safety standards. Electrical work should only be performed by qualified individuals who are familiar with the NEC and safe work practices. Improper electrical work can be dangerous and can lead to fires, electric shock, or other hazards. If you are not comfortable performing electrical work, hire a qualified electrician. When working on electrical equipment, always de-energize the circuit before beginning work. Use a voltage tester to verify that the circuit is de-energized. Lockout/tagout procedures should be followed to prevent accidental re-energization of the circuit. Wear appropriate personal protective equipment such as safety glasses, gloves, and insulated shoes. Work in a well-lit area and keep the work area clean and free of obstructions. Avoid working on electrical equipment in wet or damp conditions. Be aware of the location of other electrical equipment and potential hazards in the work area. If you are unsure about any aspect of the electrical work, consult with a qualified electrician. The NEC is a complex document, and it can be difficult to understand all of the requirements. There are many resources available to help you understand the NEC, including books, websites, and training courses. Consult with a qualified electrician or electrical inspector if you have any questions about the NEC. By following the NEC and safe work practices, you can ensure that electrical installations are safe and reliable. This helps protect people and property from electrical hazards. Remember that electrical codes and standards are constantly evolving. Stay up to date on the latest changes to the NEC and other relevant standards. The NEC is a living document that is updated every 3 years to reflect new technologies and safety practices. Staying current with these changes is essential for ensuring compliance and safety. Consider the specific application and environment when selecting electrical equipment and wiring methods. Factors such as moisture, temperature, and the presence of corrosive substances can affect the performance and longevity of electrical components. Choose products and methods that are designed for the specific conditions in which they will be used. Pay attention to the details of electrical installations. Small details, such as proper wire stripping, secure connections, and correct torquing of screws, can have a significant impact on the safety and reliability of the installation. Take the time to do the job right and double-check your work to ensure that everything is installed correctly. Document all electrical work that you perform. Keep records of circuit diagrams, equipment specifications, and inspection results. This documentation can be helpful for troubleshooting problems and for future modifications to the electrical system. Maintaining accurate records is a good practice and can save time and money in the long run. Consider the long-term implications of electrical installations. Choose products and methods that are durable and reliable and that will meet the needs of the application for years to come. Avoid shortcuts or compromises that could lead to problems in the future. Planning ahead and investing in quality materials and workmanship can pay off in the long run. Electrical safety is everyone's responsibility. Be aware of the potential hazards of electricity and take steps to protect yourself and others from harm. Educate yourself about electrical safety practices and follow those practices whenever you are working with electricity. Report any electrical hazards that you identify to the appropriate authorities. By working together, we can make our homes and workplaces safer from electrical hazards. If the heat sealer is modified or altered in any way, it is important to ensure that the modifications comply with the NEC and other applicable codes and standards. Any modification should be performed by a qualified individual, and the equipment should be re-inspected to ensure that it is safe and reliable. In addition, any changes to the equipment's electrical characteristics may require a re-evaluation of the circuit sizing and overcurrent protection requirements. It is essential to consult with a qualified electrician or electrical engineer to ensure that any modifications are performed safely and correctly. This includes verifying that the grounding system remains effective after any modifications. The safe and reliable operation of electrical equipment depends on proper installation, maintenance, and adherence to established codes and standards. By following these guidelines, we can minimize the risk of electrical hazards and ensure the safety of people and property. Remember, when in doubt, consult with a qualified electrician or electrical inspector. They have the knowledge and experience to help you with any electrical questions or concerns you may have. Their expertise can ensure that your electrical installations are safe, compliant, and reliable. Electrical systems are complex and potentially dangerous, so it is always best to seek professional guidance when needed.